cold waters carry essential nutrients from the ocean's lower depths to the hungry surface plants.
Of the water increases, and as that happens, the water actually expands and takes up more room. The other thing that happens is that ice that was on land in the form of glaciers and ice sheets begins to melt, and as that runs off into the ocean, it increases the water in the ocean, and it actually raises sea level as well.
Not all oceans have the same salinity. In fact, the North Atlantic Ocean tends to be the saltiest, much more than the Pacific.
Differences in temperature and salt content of the water cause some areas of water to sink and some areas of water to rise. And so we tend to see the sinking water at the poles, the water rising back up at the equator, and if you connect the two together, what you have is an overturning that's deep in the ocean. It's like a big conveyor belt that operates in the ocean.
This overturning moves warm water from the tropics toward the poles and cold water from the poles toward the tropics. In this way, the overturning regulates Earth's climate.
Look at New York in the northern hemisphere and Buenos Aires in the southern. We'll start a 24-hour clock for each when they pass through into daylight, and we'll stop the clock when they go into darkness. As you can see, New York has about 15 hours of daylight, while Buenos Aires has only 9.5.
Water moves around the Earth from the oceans to the atmosphere to the land and back to the ocean is called the water cycle. Water regulates climate, storing heat during the day and releasing it at night, and carries heat from the tropics to the poles by sea and by air. A molecule of water escapes into the air as a gas. This scientific visualization shows how water evaporation, indicated in turquoise, is driven by the energy of the sun.
Light and the presence of nutrients in the surface waters make phytoplankton growth possible. Physical processes, like ocean circulation and upwelling, help to regulate the distribution and abundance of the plants. For the last decade, scientists have used satellite measurements of ocean color to determine the global distribution of phytoplankton. Excessive phytoplankton growth can result in an area known as a dead zone, when big blooms of phytoplankton at the surface trigger large quantities of organic matter, which then sink to the bottom. Bacteria break down the organic material, releasing carbon dioxide but absorbing oxygen as they work. Most marine organisms need oxygen for survival, and dead zones prove fatal for many aquatic species.